what we're going to do is we're going to solve systems of equations by graphing. That'll be our third and final method. So up until now, everything's been algebraic, right, with pen and paper and writing it out. Before we actually get started, we're going to remind ourselves what it means to have a solution. So what is a solution to a systems of equations? It's an x and a y value. It's a point on a graph where two lines cross each other, right? That's why we call it a systems of equations. So if you had just one line, that's just a linear equation. If you have two lines, it's a system of equations. Where they cross each other is the answer. We're going to quickly look at these three. We're going to graph them, and then we're going to draw some conclusions, and then we're going to practice some harder graphing questions. We're going to do the top line in red and the bottom line in blue. You don't need to worry about graphing right now, because we're going to do these ones by hand. These graphs are in slope y-intercept form, right? Y is by itself, x plus 5. That means I know this red line should have a y-intercept at 5, roughly about there. And I know that it should be going up 1 over 1, so it should be making a line somewhat like that. The blue one, I know, has a y-intercept at positive 1. Estimating it to be there. And it has a slope of negative 1, so that means it goes down 1 over 1, and it should look something like this. These two equations would have one solution right there. So graphically, that's what it's going to look like. We're going to be graphing things and finding where they cross each other. Excellent. That's one situation that can happen, and that's what happens like 99% of the time, that there's one solution. However, there is multiple situations that could happen.
You're doing this, like on a question, you should put it into the calculator, right? Not just guess.
Yeah. This is just showing you the different situations that could happen on your calculator. This is one situation. It's definitely like our main situation that there'll be one answer. But there is two other situations that could happen with lines. And we're going to estimate a little sketch again to see what these situations look like. So the top one will be red, the bottom one will be blue. The top one has a y-intercept at negative 8, slope of 2. Looks something like that. Rough estimate. The blue line has a y-intercept at positive 6 and a slope of 2. So it looks something like that. Solutions are where lines cross each other. Where would the solution be on this graph? There would be no solution. The reason there'd be no solution is because they don't cross each other. They don't cross each other because they have the same slope and different y-intercepts. So these are parallel lines. Parallel lines never cross each other. So you could look at an equation and be like, oh, same slope, different y-intercepts. There's going to be no solution to this question. Now, you could just graph it like we just did and then realize there's no solution. Right? That could work too. This rarely happens, but it does happen every once in a while. The third situation that you'll need to know is this one. We can't rough estimate this yet because this thing is not in slope-intercept form. So we will get it in slope-intercept form. So we're going to rearrange it to get it in slope-intercept form. We're going to add 2y to both sides. So we have 6x minus 4 equals 2y. And divide everything by 2. So this equation is 3x minus 2 equals 1. I just rearranged it really quick. You don't need to stress about the rearranging. You can write down the steps. But what I really want you to focus on is what happens when we graph these two lines. So if I go to graph the first one, y equals 3x minus 2, and has a y-intercept of negative 2, it goes up at about a rate of 3. I don't know what that looks like. This second line in blue, these equations look very different. When we rearrange the blue one, what did it end up looking like? It's the exact same equation. It's 3x minus 2, which means I would have the exact same line. If solutions are where lines cross each other, and two lines are the exact same, then they're crossing each other all the time, right? And these lines go forever. So we call this infinite solutions. When you have two lines that cross each other, they're infinite solutions, when they're right on top of each other. Okay, that gives us our three situations, which we're going to sum up on the next slide. And we're going to put all these into a nice little chart. Your three situations are 0 solutions, 1 solution, or infinite solutions. And as long as you have two straight lines, you should always end up with those three situations. If you wanted to draw what no solutions look like, you would just draw parallel lines. Parallel lines that have different y-intercepts. That means to get no solutions means that your lines have the same slope, different y-intercepts. Makes sense, right? If they have the same slope but different y-intercepts, they would never touch each other because they're always going up at the same rate. If you got one solution, that could look like anything. I'm just going to draw it like this. With X. Your picture could look like anything as long as they cross once. That'll happen anytime you have different slopes. No matter what. If I give you two lines and one of them has a slope of 1.9 and one of them has a slope of 2, they will cross each other at some point because they're not parallel. So if you ever see different slopes, there must be an answer somewhere on your page. The third situation can sometimes be the hardest to recognize. That's when you have two lines right on top of each other. It's hard to draw it. That's when you have the same slope same y-intercept. It is very possible that you could be given a question and the answer isn't what is the solution. The question would be how many solutions are there? And you wouldn't actually have to do any math or solve it. You could look at them and be like, oh, same slope, different y-intercept, there's one solution, or no solutions. Different slopes, one solution. Exact same lines, infinite solutions. And you can do the question that fast. Right? So that is possible to be able to use a trick like that to get through something fast. Alright, now we're actually going to start graphing. So, consider the systems of equations. There's two systems right here. That's number 1. That's number 2. We're going to solve through graphing. We're going to do this together. So we're going to go step by step. To graph these things, just a little bit of review, you're going to go to y equals on your calculator. So it's the very top left-hand button. In y equals, in y1, you're going to put 3x plus 10. In y2, you're going to put negative 0.5x plus 3. Remember that the negative button is the one beside the decimal. This is not subtract 0.5x. If you put subtract 0.5x, your calculator will say error. You want negative 0.5x. The next thing you do before you graph is you're going to set your window. Right? So you're going to click on the window button, click next to y equals. That's going to take you to a page that says all kinds of things. It's going to say x min, x max, and then scale. Then it's going to say y min, y max, y scale. We always start off in what I call our standard window. Your standard window is a -10 by +10 grid. That means your x minimum would be -10. That's how far to the left you want to see on your graph. Your x max would be +10. That's how far to the right you want to see on your graph. And your scale will just always be 1. Scale is what it's counting up by. And that's what a scale is. The y min, again, -10, so that means we go down 10 from the origin. Y max is +10, that means we go up 10 from the origin. And y scale is 1, meaning that it's counting by 1. You can then hit the graph button, top right-hand corner. When you hit graph, you should get something that looks like this. The red one should be pretty hard to see. The blue one's going to look something like this. Those okay guesses? Not that far off. Do I have them crossing in the right area-ish? Good. That's a good guess. The solution to your systems of equations is right here. Your calculator can tell you exactly where that point is. To be able to do that, you're going to go second, trace. That'll bring you to a whole menu of things. So you have the second button right here, the trace button beside the graph button. It brings you to a whole option of things, right? Which one of those options do you think would tell you where two lines are going to intersect each other? The fifth option is intersect. Click that. So you're going to hit the fifth option. It's going to bring you right to your graph. You should have a cursor somewhere on your graph. And your cursor's probably on this line, the red one. Probably. If it's on the blue line, that's fine. It doesn't matter as long as the cursor's somewhere on there. Is anybody stuck? Not with that spot. After you hit second trace to intersect, it should have brought you back here. Your cursor should be somewhere on your graph. And on the very bottom, it should be saying first curve. Yeah? That's asking you to show it a spot on the graph where these things cross each other, but on the first line that you want to consider. Use your left and right arrows to move your cursor close to my green dot. You don't have to be right on it, you just have to be close. Make sure you use your left and right arrows, not your up and down arrows. Okay, you want to slide left and right along this line, or this line, whichever one it's on. Once you get close to the green dot, hit enter. Now what's it say on the bottom? Second curve. It wants to know a point on your graph that your second curve is close to. It should already be pretty good. Like it should have guessed pretty close. If you look at your cursor, when it said second curve, was it pretty close to that spot? Yeah, because your calculator's kind of figuring it out as you go. So you hit enter one more time. On the bottom of your graph, what does it say? You don't want to guess, you want the actual answer. Hit enter one more time. And now on the bottom of your graph, it should tell you x equals y equals. What did it say x equals? And what did it say y equals? Therefore, your answer to this systems of equations is -2, 4. And we could solve that algebraically just like we did with substitution, just like we did with elimination. So this is just a third way of solving things. Find where they cross each other. How do you feel about that? Way easier. So I actually teach you guys this somehow, or else people just ignore me. The reason that we don't do graphing every time is because graphing doesn't work every time. So there will be situations where you want to use a different method. And we'll talk about that in a little bit. Algebraically verify your solution. So we did do this one day. But we're going to do it again. If you ever see the word verify your solution, what that means is take your answer and put it into your equation. So, equation 1 was y equals 3x plus 10. Equation 2 is y equals -0.5x plus 3. What we're doing is we're checking to see that that actually is a point on each graph. You're going to take your y value of 4 and change y to 4. You take your x value of -2 and change x to -2. See how I've changed my values to be the thing I said the answer is? You then can put this in your calculator. That's 3 times -2 plus 10. If you put that in your calculator, you'll end up with 4 still on the left side, and the right side should equal 4. 4 equals 4 makes sense. So that is verifying your solution. This point actually does exist on this line. You then do the same thing with the second equation. So I want you to try the second one on your own. So put the y value and the x value into the second equation and see if they both equal each other, both sides. Give it a shot. Okay, so I showed it up here what it should look like. You can change y to be 4, x to be -2. If you calculate the left-hand side, you go -0.5 times -2 plus 3 in your calculator, exactly how it's written. It should turn into 4, and the left-hand side is still 4 because there's nothing else over there. 4 equals 4 is true. That means this is the right answer to your question. You should not be completing unit tests or quizzes early in this unit, unless you've done that for almost every question. If you legitimately can. Right? So you go through and check so many of your answers, so you might as well do it. All right. Oh, that was not what I wanted to do. This is the step-by-step instructions that we just talked about how to solve it. You don't need to write anything on this slide. Remember that each lesson, 6.1, 6.2, 6.3, had an instruction page on it. This is your instruction page. So if you forget how to graph, there's all the answers to you. We're going to do 2 word problems where graphing might be useful. The first one says, a local high school student council decided to sell hoodies. Decided to see hoodies. I forgot this question's full spelling. Sell hoodies. The cost of designing the hoodies was $600 plus $5 for each hoodie. So we need to create an equation for the cost of hoodies. The cost of hoodies is going to be C for cost equals. It was $600 plus $5 for each hoodie. There you go. 600 plus 5 each. The students' council planned to see them or sell them. Each their own. To sell them for $25 each. The cost and revenue can be represented by the following equations. Okay, so down here, revenue of sweaters. To create a formula for revenue of sweaters. Revenue means how much money you're making. How would you figure out how much money they make? Yeah, $25 for each hoodie they sell. And I know later in the question it says that you can do some different. They use different letters than we do. I'm going to leave it with H because people understand that it's hoodies, and that's just a little bit easier. This is a systems of equations. That means we could graph these two things and figure out where they cross each other. The reason that would be useful is then you would know how much revenue you need to cover your costs. Right? See how that would link together? You could solve this using any method you prefer. I think the best way to do a question like this is graphing. My reasoning being is that both of these letters are already isolated by themselves, and I'm just going to pretend that those are Y, and that H is X. See how they're both set up nicely? They're already isolated for Y. That means they could both be graphed really easily. That's what I would use graphing. When both equations are isolated for Y, graphing is probably your best option. Let's try graphing it together. There's going to be a problem when we go to graph this, so we're going to do it together. You're going to go to your Y1, your Y2, so you hit Y equals. Make Y1 600 plus 5x. Make Y2 25x. The problem's going to be your window. So once you've done your Y equals, go to your window setting. We're going to need to talk about that. Alright, the reason your window setting is going to be a problem is if you did your standard window, you wouldn't see anything. The reason why you wouldn't see anything is because your standard window wouldn't make sense for this context. Let's talk about what I mean in a second. X minimum. Before we used to just say minus 10 because that was our standard window. But this is a word problem. So that means X actually represents something. What does X represent in this question? The number of hoodies sold. So what's the minimum number of hoodies you could sell? X minimum of 0 makes a lot more sense. X maximum. X means hoodies. What's the maximum amount of hoodies you think would be fair for a student council to sell? I think if you were a student council and you sold like 100 hoodies, you're probably doing pretty good. Is that safe to say? Yeah, right? Like that's just a reasonable guess. Nobody here knows what their actual maximum hoodies sold could be. I just need to do a reasonable guess. 100 seems pretty reasonable to me. Y minimum. Looking at your questions. Y was cost and Y was revenue. So what's the minimum amount of, say, revenue you could get? 0. You sell no hoodies, you get no revenue. So Y minimum of 0 makes sense. Y maximum. Y is cost and revenue, right? Maximum revenue, you could go forever. Maximum cost, you could go forever, right? The more hoodies you sell, the higher it's going to go. But we need to put some sort of limit on it. 600 is my basic cost no matter what, right? If I sold no hoodies, I have a cost of $600. So a good maximum cost, like a reasonable one, maybe like $2,000. That would be selling quite a few hoodies. But I think if I had a maximum cost of $2,000 or a maximum revenue of $2,000, that's pretty good, in my opinion. Now you can graph this thing, and you should get a graph that looks somewhat like this. You should get one curve that comes straight out of the bottom, and it should be going up pretty steep, like that. No? Too steep? Not steep enough. Too steep. That worked out pretty well. And then you should have another one goes something like this. That's a little rough, but that'll work. You should have two lines. Yeah, you should have two lines on your graph, both of which are increasing. You should be able to see where they cross each other. If you couldn't, so for instance, say we graph these things and we couldn't see where they cross each other. We can only see this part of the graph. Then I would go back to my window and I'd just make it bigger. Right? I'd be a bigger X max, bigger Y max, so I could see more. Setting the window is easily the hardest part of a word problem. It's the part that people get thrown off on the most. All right, we're going to take this beautiful graph, and we are going to answer some questions on the next slide with it. B, how much profit or loss is made if 20 sweaters are sold, 50 sweaters are sold? That's, you could do with your graph, but we wouldn't because that's way too much work. That means you're going to go back into your formulas and you're going to calculate what happens if you sell 20 sweaters. So if I sell 20 sweaters, hoodies. Hoodies, sweaters, same thing. Hoodie is a sweater, sweater is not a hoodie. All boys are humans, but not all humans are boys. Logic. You're going to come back to your formulas, and you're going to figure out the cost and the revenue for 20 hoodies sold. So, my cost would be 600 plus 5 for every hoodie sold. Right? You could use these formulas to actually answer questions. That's going to equal $700 in cost. Then you have to calculate your revenue. Your revenue was 25 times every hoodie sold. In that case, should be 500. If my revenue is my cost is 700 and my revenue is 500, did I make money or lose money? I lost money, right? Spent 700, made 500. That means I lost $200. Does that make sense? I want you to try 50 sweaters on your own and see if you can come up with a value for it. So you're going to put 50 sweaters into your cost equation, 50 sweaters into your revenue equation, and see what you get. All right, if you do those calculations, your cost should have been $850, your revenue should have been $1250. You subtract those from each other to figure out how much money you would have made. In this case, you had a profit, that means you made money, of $400. $1250 is 400 more than $850. Okay, that's using the equations. We've done that stuff before. That should have been from Unit 5, a little bit of Unit 4, where we built equations, calculated things. Question C is a lot more this unit. So it says, the break-even point. Break-even is a term that you'll see in business. That's where you make no money and you lose no money. Okay? It's a spot right on the graph where you're perfectly in balance. Circle that point on your graph. That point on my graph is right here. Right? That's the break even. I make no money, I lose no money. Determine the number of sweaters sold to break even. So if you want to figure out when you break even, you need to figure out where these two lines cross each other. To do that, using your calculator would probably be ideal. So I want you to see if you can remember how to find where two things cross each other. So you should have this graph up on your calculator. You're going to use second trace, right? After you go second trace, you're going to pick one of those options. Intersect is probably the best option to use. Then you're going to go left and right in the first curve till you're close to that point. You're going to hit enter. You're going to hit enter again. You're not going to want to guess, so you hit enter one more time. So, second trace, intersect, enter, enter, enter. Your calculator should tell you where those two things cross each other. What's the x value where they cross each other? 30. What's the y value? All right. That point, 30, 750, it means something. It means that when you sell 30 hoodies, your cost and revenue are both 750. That's your break-even point. $750. Or 30 hoodies sold. Right? Depends how you want to look at it. They'll always word the problem so that you need to know which one of these to answer. So if you look at your question, it says, determine the number of sweaters sold to break even. The number of sweaters needed to be sold would be 30. 30 hoodies sold would break even. Anything more than 30 sweaters, I make a profit. Anything less than 30 sweaters, I lose money. That's how this unit is applicable in real life. Like I said, this is actually probably one of the most applicable units you ever do. It just gets on a way bigger scale as you learn more and more about it. But any business that gets run has some sort of idea of this, where it's like, this is how much it costs my business, this is how much money I make. I need to figure out where I break even so that I can always stay above that point. It's just like running a balance for a household, right? This is how much it costs me to run my household. This is how much money my household makes. I need to always break even or be above it. Like, this is actually useful stuff. The equations just get more complicated. We're going to skip question E. If you want to try that on your own, you're more than welcome, but it's pretty much the same thing as B. It's just saying if 650 people buy hoodies, how much money would you make? Actually, we have time. I thought we had one more question. We have time. So go ahead, see if you can calculate this one on your own. I'll go through it in detail, but try it on your own. See if you can figure out how much profit would you make if you sold 650 hoodies. If you wanted to figure out how much profit you would make, you would take your revenue formula. Your revenue formula is 25 times the number of hoodies, which would be 650. How much revenue would I make? 1,600 and what?
16252.
There we go. Then that's way too small. 16,650. If you had to figure out your costs is 600 plus $5 for every hoodie. What number was that equal to? Awesome. You want to figure out your profit. You're trying to figure out the revenue minus your costs. If you do that, you should end up with 12,400. Gorgeous. That's how much money you would make. You would make $12,400. That's called profit, right? So remember, profit and revenue are different things. Sometimes people mix them up. Revenue is how much money you collect. Profit is how much money you're making after you consider your costs. There's lots of companies that can make a lot of revenue, but their costs are way more than their revenue. I think Snapchat does that. Snapchat's costs are way more than their revenue. Selling ads.
Yeah.
Okay.
And